Okay, so let's talk special right triangles. So, when it comes to special right triangles, there are relationships, or let me back up. There are actually two types of special right triangles I want to talk about. So, those two triangles are a 45-45-90 and a 30-60-90. So, because these triangles have these special angles, these special properties, I can actually solve them without having to do a whole lot of work. So we're going to talk about a couple examples of special right triangles. But I went ahead and wrote these notes down as a way to consolidate time and maximize the examples. Okay? So first type of special right triangle I have, 45-45-90. So the relationship between these triangles is a 1-to-1 to the square root of 2 ratio. And quick summary, if you will, because both of these angles are 45 degrees, their opposite sides are congruent, and then 1 squared plus 1 squared is the square root of 2, and that's why, or 1 squared plus 1 squared is 2, and the square root of 2 squared, the square root of 2 is 2 squared. Basically, all that to say, this is why the relationship is it, but it'll make more sense when we start doing a couple practice problems. So, real quickly, a 30-60-90 triangle falls under the same category. It has the same type of relationship, a 1 to a square root of 3 to a 2 relationship. Opposite the 30, opposite the 60, opposite the 2. Okay? So, a 1, square root of 3, 2, all dependent on what x is. Okay? So, let's talk about, or rather, let's do a quick example of a 45-45-90 and then a 30-60-90 and see how to find the values of special right triangles. I'm trying to keep all my papers up here at once. All right. So, say for example, I have a right triangle. This value right here is 3. This is a lower a. This is C. Little fun fact. I don't know if you ever noticed, but angles are always capitalized and sides are always in lowercase. Little thing. So, we take a look at the previous ratio of a 45-45-90 triangle. So this is 45 and this is 45. So, the 45-45-90 ratio gives me a 1 to a square root of 2 ratio, or 1x to 1x to the square root of 2 times x ratio. So, what that tells me is that I can basically plug in these numbers. Okay, so I'll just go ahead and write it out. A 1 to a square root of 2, then a 1, I don't know what that x is, to a 1, I don't know what that x is, but they are the same. Square root of 2 times whatever x is. Okay? So, I know that the value of CA is 3, and because opposite sides are congruent, when we're talking about opposite sides of congruent angles are congruent, so I can rewrite this as a 1 times 3, and then a 1 times 3 ratio, because this is my x, this is 3, that goes here, so also goes here. And then my last ratio, square root of 2 times 3 in parentheses, and we'd actually write that in opposite order. So my side lengths are 3, because 3 times 1 is 3. 3 times 1 is 3. And then 3 times the square root of 2 is, you can write that as 3 square root of 2. So that tells me, well, A, this side right here, A is equal to 3, and C is equal to 3 square root of 2. Okay, so next we're going to talk about, okay, I went ahead and got started a little early on this example so I can take a little time to explain a few things on a 30-60-90. But basically, you got a 30-60-90 triangle with a hypotenuse, darken that up a little bit, with a hypotenuse with a length of 30 and two missing sides. So once again, we got a 30, 60, 90. We need to find the missing sides. How do we go about doing that? So just as I stated before, a 30, 60, 90 has a 1 to square root of 3 to 2 ratio. Okay, so that means whatever x is, it has a 1 times x, a square root of 3 times x, and a 2 times x ratio, with the 90-degree side being the 2x ratio. So up here, I want to solve for x. If I know what one of the sides are of a special right triangle, well, that goes a long way in me in figuring out what x is. So I know that side BA has a ratio of 2x, or it's 2 times x is equal to 30. Okay, so I'm going to use BA as the side. Okay, so basic algebra says I divide both sides by 2 and get x equal to 15. So this x here that goes down here, here, and here is actually equal to 15 and not 30, because 2 times x gives me the 30 of the hypotenuse. Okay, so, but regardless, now I've got my value of x. So it'll be 1 times 15 square root of 3 times 15, and then 2 times 15, which we found out to be 30. So the 2 times 15 is opposite the 90-degree angle, which is 30. The square root of 3 times 15 is opposite the 60-degree angle. So my B, right here, will be equal to 15 times the square root of 3. And my C is opposite the 30-degree angle, or excuse me, my A, sorry. My A is opposite the 30-degree angle, and A is equal to 1 times 15, which is just 15. Okay, so that's how we go about solving special right triangles. We take advantage of this ratio. We're going to do another video where we're not going to know the measure of the hypotenuse, and then we'll try to find the measure of one of the sides, setting up the ratios.